Hi everyone, welcome back to my channel. Today we're tackling a fascinating question. Why is gravity, the force that holds our entire universe together, so much weaker than other fundamental forces like electromagnetism and the strong nuclear force? Let's dive into Einstein's theory of general relativity to find out. First, let's set the stage by understanding what we mean by gravity being weak. We have four fundamental forces in the universe: gravity, electromagnetism, the strong nuclear force, and the weak nuclear force. When we compare their strengths, gravity is significantly weaker. For example, the electromagnetic force between two electrons is about 10 to the power 36 times stronger than the gravitational force between them. To understand why gravity is weak, we need to look at Einstein's field equations in his general theory of relativity. These equations describe how matter and energy interact with the fabric of spacetime. The equation looks like this. Now let's simplify this equation to understand it better. We can approximate it as the following. This tells us that the energy-momentum tensor, which describes the energy and matter, is proportional to the spacetime curvature multiplied by c to the fifth power. Why is this important? Because c to the power 5 is a huge number. In fact, c to the power 5 is approximately 10 to the power 42. This means an enormous amount of energy is required to create even the smallest curvature in spacetime. The energy-momentum tensor T-mu represents the density or distribution and flux of energy and momentum in spacetime. The curvature of spacetime, G-mu, on the other hand, describes how spacetime is warped by the presence of mass and energy. This, in a sense, is the equation which can be regarded as the generalization of Einstein's popular equation that relates matter and energy, that is, energy is equal to m times c squared, where c is the speed of light in vacuum. Because of the c to the fifth power factor, even a tiny amount of curvature in spacetime requires a massive amount of energy. This is a key reason why gravity is so weak compared to other forces. Now let's understand what it means for a force to be strong or weak and compare this with other forces. The strength of a force field lies in its ability to transport force. The more easily it does this, the more strength the field has. Easy here means requiring less energy to create the disturbances in the field and hence transport the force. Disturbance in the field is what defines force. The electromagnetic force, for example, doesn't need such a huge energy factor to create disturbances. The fields associated with electromagnetism, the strong nuclear force, and the weak nuclear force can be easily disturbed, which makes them much stronger. The ease with which these fields can be disturbed allows them to carry stronger forces. In contrast, the field of spacetime requires much more energy to create disturbances, making gravity the weakest of the fundamental forces. So why is gravity weak? The answer lies in the enormous energy required to disturb the spacetime field, as indicated by Einstein's field equations. This high energy requirement means that creating even a small dent in the fabric of spacetime is incredibly difficult, unlike the fields of other fundamental forces. In conclusion, gravity's weakness is a result of the immense energy needed to disturb the spacetime field. This sets it apart from other forces, which can be easily disturbed and therefore carry stronger forces. Thank you for watching. If you enjoyed this video, please like, comment, and subscribe for more deep dives into the mysteries of the universe. See you next time.